Assalamu alaikum dear students. Today we are going to start section 6.2. In this section we are going to learn the new method for finding solution of solid of revolutions. So let's see how does this method work. So first of all, again we are talking about solid of revolution. You already know what is solid of revolution, and another method, shell method, is introduced to solve the to find the volume of the solid of revolution. So the question arises here, why do we need this new method when we already have disk method and washer method? The problem here is sometimes finding the volume of a solid of revolution is impossible, literally impossible by the disk or washer method. For example, if we have to rotate this function, the graph of this function is shown here, 3x minus x square, y is equal to 3x minus x square, and we want to rotate it vertically around the line x is equal to minus 1. Now what we need to do, if we have to apply Washer's method, we have to find the outer radius and the inner radius. So you can see the outer radius and inner radius are using same curve. So this is hard to write the radii in terms of y. So in this case, if such problems occur, we can seek help from the method we are going to learn now. So here is the new method. We are going to subdivide the interval into smaller subintervals, and we draw a rectangle and let this rectangle rotate around the axis. Okay. So this makes a shell, right? You can see all these rectangles are rotating into cylindrical shells. And these shells, now we can find the volume of one shell, and adding all these volumes, we will have the volume of the solid of revolution. So this is actually the solid of revolution. So let's have an arbitrary shell created by a rectangle after rotation. So this is the arbitrary shell. So what is the volume of this shell? Volume of this shell is, in order to find the volume of this shell, just cut it and unroll it. And we have this rectangular box. So volume of this rectangular box is actually height multiplied by this thickness multiplied by this length. So what is this length? Height is in fact the height of this shell, and this thickness is in fact the length of the interval, that is the width of the rectangle. And what is this length? This length is actually outer circumference of this circle, right? So what is the value of the circumference of a circle? This is equal to 2 pi multiplied by the radius. So what we need to do, we need to find radius, we need to find height of this shell, and we have thickness, so we have volume then. So volume of this shell is equal to this circumference, that is perimeter, multiplied by height multiplied by thickness of the shell. So this is 2 pi r times height times thickness. Now, in order to find all these values, that is thickness and height, in terms of known values, let's see, let's do some manipulations. So this is the actually arbitrary rectangle drawn on the kth interval. Width of the interval is delta xk. And what is the height of the interval? Since this height of the rectangle, since this is the graph of y is equal to fx, then height of this rectangle must be f of x ck, f of ck, because reference point is ck here. So f of ck. So delta xk is the thickness, fck is the height. Now what is left? radius. So 2 pi times radius is required. So what is the radius? Radius is actually, now we are revolving this rectangle around this axis. So radius of the rotation is the distance of the rectangle from the axis of rotation. This is the radius. Okay. So what is the value of this distance? This is, in fact, this point is xk, and this is x is equal to L. So what is the radius? Just difference between these two values, that is xk minus L, right? So whenever you have to find the length of the interval, now this is actually interval Lxk. Whenever you have to find the length of the interval, you just need to subtract the initial value from the terminal value of the interval. So this is the length of the interval, and this length of the interval is in fact the radius of the shell. All right. So this is the delta V. Now, or delta Vk, you may say. Now, Riemann sum converges to an integral as we let delta k approaches to 0. Then this becomes integral of a to b, integral of 2 pi x minus lfx dx from a to b. So this is the formula for volume, and here is the formal form of this formula. The volume of the solid generated by revolving the region between the x-axis and the graph of the continuous function y is equal to fx, which is greater or equal to 0, uh, and x lies between a and b, and a is greater or equal to L. About the vertical line, x is equal to L. So volume is equal to integral from a to b 2 pi shell radius times shell height dx. So this shell radius is nothing but the distance from axis of rotation to a typical triangle, and this shell height is height of that typical triangle. And in order to have a vertical in order to have the rotation about a vertical axis, we will have dx here, and when the axis is horizontal, we have to use dy. So summary of the shell method. Well, regardless of the position of the axis of revolution, whether it is horizontal or vertical, the steps for implementing the shell method are same, and which are as follows. Number 1, draw the region and sketch a line segment across it parallel to axis of revolution. So in previous section, we talked about the method of disk method and washer method. In both the methods, there were the cross sections perpendicular to the axis of revolution. Now, in this case, we are going to draw the rectangular regions parallel to axis of revolution. Label the segment's height or length, which is called shell's height, and distance from the axis of revolution, and this is called shell radius. Find the limits of integration for thickness variable. Integrate the product 2 pi shell radius, shell height with respect to the thickness variable x or y to find the volume. Okay, let's solve few questions. Rotate the region between the curve y is equal to 3x minus x square and the x-axis, that is this region. About the line x is equal to minus 1, that is this line. So, and then find the volume of the solid of revolution. So, find the volume of solid of revolution. Okay. So, we need to find, let me write the formula. We have formula a to b 2 pi times shell height shell radius dx. Now because we are rotating it about the vertical line, so therefore there is dx. So 2 pi, here is 2 pi. A, B, x varies from A to B because we have to find the limit of x in the region. So x varies from 0 to 3. So A is 0, B is 3. Now what about shell height? Shell height is value of the function. So this is how we will draw the rectangle. So shell height is value of the function, which is 3x minus x square. And what is shell radius? This is the distance of this rectangle from this. Okay. So what it's going to be, let this point be x, and this point is minus 1. So we have the interval minus 1 x, and we have to find the length of the interval, which is the radius. So the radius is x plus 1. Okay, so length of the interval is x plus 1. This is r. So this is r, this is h, right? And rest you know very well how to solve it. You just have to evaluate a different angle, and you have the volume, which is 45 pi by 2. Okay, next. Example, the region bounded by the curve y is equal to square root of x. So we have function y is equal to square root of x and the x's. So this is the region in blue color. And the line x is equal to 4. So this is bounded by line x is equal to 4. Is revolved about y-axis. So in this case, we are going to revolve about y-axis, that is about vertical line, to generate a solid and then find the volume of the solid. So first of all, the first step to follow the instructions. First step, sketching. So sketch the region and draw the line segment across it parallel to axis of revolution, right? So this is the shell height. This is the radius, x, which is the radius. This is the shell height. Now in this case, we have the interval 0x. What is the length of the interval? This is x. So this is the radius. And shell height is fx. And what else we need? We need A and B. So A here is 0 and B here is, because we are rotating vertically around the vertical axis, around the vertical axis. So our function is going to be the function of x. So we have to find the limit for x. And rest is just a matter of calculation. You can do it very well. So here we go. This is the one, right? So this is the shell radius. This is the shell height. This is these are important things actually. If these are determined, then nothing to worry about. Now we are going to solve same question, but with a little bit twist. That is, we are going to revolve around x-axis this time, and we have to find the solid of revolution generated, and again we have to find the shell height and shell radius. Now in this case, shell height will be this distance, because we are going to subdivide this interval into subintervals and drawing the rectangle. So this is our rectangle. So what is the length of this? We have to find the height, and what is the radius? Radius this time will be the length of interval along y-axis, right? So this is the radius, this is the this is the radius, this is the shell height, and shell height is since this is y is equal to square root, this is the graph of y is equal to square root of x, x is equal to y square, right? X is equal to y square. So we have and this is bounded by this line. Okay. So what is the value of this rectangle? What is the height of this rectangle or length of this rectangle? This is going to be 4, x is equal to 4, and at any point on this curve x is equal to y square. So this is going to be 4 minus y square, right? 4 minus y square. So this total length is 4. We have to subtract this to obtain this length. So what is this? This is y square. because this point lies on the curve. So 4 minus x square is shell height. Shell radius is y. So rest is just plugging in the values in the formula. So let's do it. And y varies from 0 to 2. So therefore a and b are 0 and 2 respectively. So by solving this in time, we have volume which is equal to 8. And finally, there is a comparison of methods we have learned so far. So methods we learned: disk and washer method. In this case, typical rectangle is perpendicular to x-axis, to axis of rotation, not x-axis, perpendicular to axis of rotation, and use dy and x is equal to gy if the axis is vertical. If axis is horizontal, use dx and y is equal to fx. Right? In shell method, it's going to be opposite. These are the typical rectangles are perpendicular. In this case, typical rectangles are parallel to the axis of revolution. And use dx when we are rotating about the vertical axis. Then use dx and y is equal to fx. And in case of horizontal axis, use dy and x is equal to g. So that's all for today. Take care.